First of all, I would like to say thank you to Invibu to ask us almost 5 years ago to start this study. The main goal it was to use this kind of product with our all-in-4 products. I start the presentation with my last slide in Madrid, and we said that we always follow the case. Today, I will speak about PIC infrastructure in multiple applications on implant dentistry as a lab perspective. Most of the things that I will start in the beginning already was told by Marcos and Dr. Carlos, so I will pass through and focus in the main object that is the PIC product. It's the one that I study, and then when I have problems, and I'll try to find solutions. This phrase, it was very nice when I saw it in the internet. If a prosthetic frame can change our quality of life. As you can see, most of the people is trying to avoid metal and ceramic in the mouth because they are too aggressive. So it was very nice when they asked us to make this study and show them that there are other options for the dental treatment. The advantages of PIC, it's very strong, it's very lightweight, and this have excellent mechanical and chemical properties. Its high strength to weight ratio, its elastic properties, it's like a bumper, and zero corrosion rate, has extremely low water absorption, and is radiolucent. So it's a very good material for use in the mouth. There is no indications of allergic reactions of this material. The PIC is ideal for long-term prosthetic frameworks over implants or over teeth or over a secondary bar. The implant prosthesis can be secured onto implant systems. This was the main goal when we started this project, this study, because in the old times, just another part, the Nova Biocare have some cylinders, provisional cylinders, that have the same problem. They were like PIC, and we have problems with the screws. It has been used in medicine for the preparation of different kinds of implants, as Marcos said. If we can use it inside of our body, why can we use it, why can we use it in dentistry? So the use of PIC is increasing and applied in dentistry. PIC become very attractive because it's very easy to make it in the CAD/CAM procedure. It's good for the machines, it's good for the birds, and it's good for the money, for us. From the little screw reinforced with carbon fiber, the healing abutment, the primary and secondary structures, to the modification of the MAB and MCB. When I say modification, the protocol of the MALO acrylic bridge and MALO ceramic bridge has titanium reinforcement. So when we change it, we will change the titanium by PIC. The MALO clinic protocol with the PIC structure has some objectives. In this kind is the follow-up of the first test. We are, since the first pilot test, we are in here almost 5 years using this product. Change the PIC structure and design according to different kinds of loading and conditions and combinations. In a few words, learn from mistakes and correct them. Now this is my area. In the beginning, we started to use just the MALO clinic protocol with all-in-4, but we just tried to use it with another kind of prosthesis to be its behavior. In this first one, we have a normal MALO acrylic bridge reinforced with PIC and regular teeth. This one is a removable prosthesis with PIC, with the MAB inferior with PIC too. This one is a bimaxillar. This is a maloceramic bridge and a removal with clasps. So, for achieve such results, we had to create a protocol. We had to see the design, the measures, the interface, very important, and the PIC finish, the bonding, the types of bonding, the opaque, polymerization, finish, and polish. Most of these things the patient don't see, and they don't know how we made it. So it's important for us, and it's important for the clinician, because we need to avoid problems in the future. For the design, we have a section 3x4, 3 of width and 4 of height. The height must be always higher than the width. Near the implant holes, we need to have at least 2 millimeters one side and 2 millimeters in the other side. It's very easy to explain. In the beginning, we use the same technique that we use in the titanium. And the problem, if the patient can break the titanium, more easily he can break this. If you have a branch, a wood branch, with 10 centimeters, if you make it a wall in the middle, it will not have 10 centimeters. To have 10 centimeters, you need to be very higher in both sides, and when you have a hole, it's a weak spot. So you have to reinforce that zone. You need to respect this. Sometimes we made it higher just to see how the product behave. It's impossible to control these measures, but we can control this. If you make it a bigger space, you can have higher the prosthesis or the bar to compensate that space. This is already the new designs. In the beginning, we had problems because after we do it, the prosthesis, most of the times the clinician had to take off a little bit of acrylic because the patient said that you don't have enough space for the tongue, you cannot speak well. So the clinician take the acrylic and we create some PIC islands. It's not bad to have the PIC islands. I will show you after. But we need to reinforce all of these zones, especially in the cantilevers. It's very important to reinforce these parts. Here we have an island, and here we make the bar in an inverted T to have more strength. When in our life, when you see some metal bars, normally you don't see metal bars round. They are like a E shape or a T, E shape or a T. You have less metal and you have the same strength. For the PIC finish, we always need to use protective caps. You will see that I'm always speaking about this. In the removables, you don't have the holes, but the material is very soft when you are burning with your handpiece. If the bird jumps and touches the cylinder, you smash the bar. Use tungsten bars to trim it, diamond bars to increase surface ruggedness. I will explain why. You need to have attention to weak spots, and the thickness control cannot be less than 2 millimeters. Threads can be made to have more retention, mechanical retention, but avoid vertical retentions. Here are I tried to put one kind of each, just to see the difference. In this, it's from that case with the full prosthesis, removable. It has a good adhesion in the mouth. So we create a lot of mechanical retentions because the acrylic does not involve the prosthesis. So if you have something that is wrapped just like this, if the occlusion is not completely well with the protrusion or the lateralities, you can break the prosthesis. The same for the removal with the clasps. This one, Dr. Carlos already showed, it's for the MALO ceramic bridge. You can see the islands have finish lines, and here, as I told you, the threads cannot be vertical, and this one is trimmed to have more mechanical retention. Bonding PIC acrylic, that is the part that we had more problems, and we talked a lot about this because it's very complicated to have something with an elastilic model higher than the acrylic inside of the acrylic. So, depending on the bonding that you are going to use, you can sand it with, sandblast it with silica or aluminum oxide, always with 3 bars of pressure at 45 degrees at a minimum of distance 10 millimeters. Jet clean it with air free of oil, but you should not steam it. Here is how the PIC looks after you sandblast it. It's the same when you sandblast it with the oxide, the aluminum oxide or silica. When we use silica, we need to use this kind of bonding. You need to apply the metal bond 1 for 30 seconds and let it dry because it's an acid. You apply metal bond 2 and light cure it for 90 seconds. This kind of bonding has a higher tensile bond strength than the shear bond. This is the aspect after you use the metal bond 1 and 2. It's a little shine, and we use this kind of machine because he has a lot of power for the polymerization. When you use the connector, you sandblast it with aluminum oxide at 3 bars, 45 degrees, all the same procedure. The only difference is you just use one layer and wait for 2 or 4 minutes just to the material to grab in the prosthesis, in the bar, and light cure it for 90 seconds. The difference between this one and the other one is the tensile bond strength. It's higher than the shear bond. And this is the aspect. It's the PIC looks like it was took some acid and is melted. It's very nice. Here in the MALO ceramic bridge, the bonding is different. I will speak, Dr. Carlos was speaking the way of cementing the crowns. We use in the lab this multi-link hybrid abutment just to cement the crowns. For the rest of the bar that will be covered with composite or acrylic, it's the same procedure that the other one. What you do is we polymerize it, and then we use a pink acrylic just to hide the frame, because the frame is too light. If you just put the acrylic or the composite over, it will be like something is dead inside. The color, it's not very nice. So you need to put pink opaque to cover it. After a lot of problems that we had, the bonding choice for this kind of works, we change from the metal bond 1 and 2 to the connector. Because of the tensile bond strength, it's much better. For the cementation, I already told that we use the multi-link and the Sigma opaque F to cover the bar. Here, you need in these parts of the cylinder, see? we don't put opaque because it's the part that will be inside of the gum. So we can see a spot that will be full of something that can be damage the implants. That one is one of the first that we make. The retentions, in that time we made it some pins. It was not so good as another retentions that we did in the other one. For the polymerization, because of the kind of acrylic that we use, that is very polyvalent, we can use it for all kind of works that you do. We use the pouring technique. It takes less time to do it because we don't need to put it in the flask, but if we want it, we can use this kind of acrylic, and we use one flask from Fast Protect that gives you very good results. Normally, if we follow the protocol, you don't have problems with vertical dimension. We just pour it, it's very simple, and you just polymerize it for 55 degrees during 20 minutes in the pressure pot. And what we have is something very clean because we use a lot of silicones. And when we take it, you just need to cut the sprues, and it's almost done. After you cut the sprues, you put in the articulator, check the occlusion. Normally, we don't have vertical dimension problems. Place the protection caps and finish normally with tungsten burrs, silicone rubber, and sandpaper. As you can see, this was the case with the upper full denture. We trim it. Normally, I use burrs for gold because they have the trim of the burr is very tight, so the finish is much better. For the polishing, it's normal. You can polish the acrylic. You use the same technique to polish the acrylic that you use to polish the pick. And the final product is very nice and very shiny. Here you can see 3 cases. Looks very nice. Now, the complications. When you start in something, you have complications. You need to solve those complications. The main problems that we have since the beginning, it was interface peak abutment. When we started, we already knew that we had problems with that, so we started thinking about how to solve it. The acrylic thickness, the peak thickness, the cantilevers, and the unbalanced occlusion, and the last one, the excessive deep bite, it was very important for this. The interface between the acrylic and the cylinder was the problem. As Dr. Carlos said, the screw passed through. The first time that they put it, it was all right. They could torque it in 10 newtons. It was nice. After the third time, the screw will come out and the prosthesis cannot be screwed. The acrylic thickness, it was a problem. This prosthesis that is here is from Dr. Carlos' uncle. As you can see, he's a gentle guy. And this was the other problems. When I said earlier that I'm going to speak about the islands and the fractures, the islands, if you need to make some islands in the bar, you need to previous study it and know where you're going to put it. If the doctor cut the acrylic and make an island, it's completely different. We can say that it's artificial because the acrylic will stop in 0. So you don't have a finish line to protect the acrylic and to protect the peak. The same problem when you have the acrylics too thin. you need to think what you want to do. In this case, see, the patient was complaining that he has no space. They cut the acrylic and exposed the peak. What happened? This zone was fragile and it could take some problems from here. Solutions: the titanium sleeves, the cantilevers, we make some islands to increase the width of the finish lines. The thickness of the acrylic, if you don't have space, you can leave it in acrylic, but you need to think it before doing the prosthesis. Increase the peak thickness in the cantilever. Take attention to the occlusion and use the right connector. This was one of the problems that we had in the beginning until we discovered the connector much better. The excessive deep bite is a problem too. That was corrected in that case that Carlos showed you, the full contour peak. Here we have the titanium sleeve. You have contact with this part over the abutment. The idea is the lower part of the cylinder will seal around the abutment. All the forces will be in here. You have like alpha cone and a chimney that will protect the screw and will fix the structure in place. Then all of the sleeve will be inside of peak and covered with acrylic, so you don't see that is there. The difference between this sleeve and the interface is the sleeve is going up and the interface is going down. When you have an interface, you have a metal joint there. Here we created more width in the acrylic. This one, it was the one that Carlos said. What we made, it was like thinking like when you have a bridge, and the bridge is near the land, you have something to dissipate the forces. So we make a full contour tooth, and then we make a veneer in this tooth. Here is some island that we plan to, and this one is this, but with the tooth. This was, of course, Dr. Carlos' uncle. He could do all of this. This was a design problem and a bonding problem, so we need to redo it. We are expecting him to do it, this kind of thing again, so we already started duplicating to prepare it to have a full contour bridge just covered with composite in the vestibular. This is a good case that we are studying, zygomatic implants. As you know, more than me, the zygomatic implants have some mobility. Probably this product will be the solution for that, because if you have some mobility, it will not be so very hard and will protect the implant. This was the original design. Then I just cut it, and thinking about the mobility, I made some mechanical retentions just to protect it from breakage. And until now, we have no problems, no breakage, and as you can see, has a long cantilever, almost 3 teeth. This is how we do it. After the opaque, we just pour it, and as you can see, it's very smooth. As I told you earlier, the part near the gum and the implant don't take acrylic for a better hygiene. And this is some cases. The first one is this one is the zygomatic, the all-on-4 normal with peak reinforcement. This is in the mouth. That one is with full prosthesis, and this one is the ceramic one. and this will be our next step for the Dr. Carlos Uncle will do the case with full of composite in the vestibular. Thank you.